Okay, so this is kind of synopsis of other videos you probably watch or watch some of those other ones I made. So just to recap, um, the number in front of the function is a vertical stretch compression. If that number is bigger than 1, it's going to be a stretch. It's growing faster. Taking the y and multiplying it by a bigger number bigger than 1, it's a compression if it's between 0 and 1, a fraction, a decimal, usually the fractions. The horizontal stretch comes out, it's a number inside the argument, and if it's a stretched out because it's taking longer to get there, if y is taking longer to get there because it's the x is getting stretched out, right? So if the b number is between 0 and 1, it's a horizontal stretch. If b is bigger than 1, it's a compression because it grows faster. Um, if the left-right shifts or that number there, it's always inside the argument. X or the input variable minus means moving right. If it's plus, it's moving left. And the up-down shifts are easy because it's always the same sign. You don't have to think about translating that into something else. So let's look at some examples from the book. So these are right from section 1.5. Some things I do, I ask myself, well, I see an absolute value function. I see that instead of having the vertex of the origin, that's been shifted right 3 down 2, so I know it's going to be x minus 3 because it's moving right, and down 2 because it's moving down. And then I see that the slope of this absolute value function is up 1 over 1, up 1 over 1, and just negative 1 on the other side. So there's no stretch. There's no vertical stretch. It's just that. I see a parabola, which you know is x squared. I see normally it's at the vertex, that turning point is at the origin. This one's been shifted right 1, down 3. So inside the argument, we're going to say minus 1 because it's to the right, square it, and outside we'll write minus 3. And then parabolas behave, if I square 1, I get 1. If I square 2, I get 4. If I square 3, I get 9, which we can't see. So there's no vertical stretch here either, just that. I see a square root function. So that's the square root of x. I see instead of happening at 0, it's happening at -3 and shifted down 1. And then square root functions, is it stretched at all? Well, let's see. I see it's over 1, up 1. Square root of 1 is 1. The square root of 4 is 2. The square root of 9, which I don't think we can graph, is 3. So it looks like there's no stretch either. And again, this is just an absolute value function. If you want, stop the video, try it, come back and watch and see what I get for an answer. Here's what I got for an answer. Y equals, let's see, I see it's shifted left 2, up 2. So x plus 2 because it's left, plus 2 because it's up, and the slope again is 1, -1, so there's no stretch. Some more toolbox functions that have been reflected also around the x-axis, both of these I would say. So I see a parabola that's shifted left 1, up 2, so x plus 1 squared plus 2, remember plus 1 on the inside because it's shifted left. And then I see it's going over 1, down 1, over 2, down 4, so there's no vertical stretch, but it has been reflected around the x-axis, so it's got to be negative there. Same thing with this cubic function. This is an x cubed function. And the vertex, it's really a turning point rather than a vertex, but that normally happens at 0, 0 at the origin. So this has been right 2, up 1. So not absolute value, x minus 2 cubed plus 1. And then over 1, down 1, over 2 should be down at -8. Because the over 1, down 1's right on, I don't think there's a vertical stretch. I do know that's reflected around the x-axis because usually x cubed functions look like that, right? Now we're looking at a couple more square root graphs. Normally square root functions look like this, right? And so I see the same function, it's just been reflected around the x-axis, so that'll be negative square root of x. Here I see normally square root functions look like this. This has been reflected around the y-axis, so that'll be inside. Oops, why did I write 1? Well, I guess it's 1, but here. Negative square root of x, because it's inside. Now we're starting to put some stuff together. I see a parabola that's been shifted left 2, up 3. So x plus 2 squared plus 3. I see, instead of going down over 1 down 1 over 2 down 4, 1, 2, 3, 4, it's more of a shift. In fact, if you look at this, over 1 down 2, over 2 down 8. So this is a stretch by a factor of 2, and it's negative because it's been reflected around the x-axis. I see an absolute value function that's been shifted right 2, up 1. I see, instead of a slope of 1, though, it looks like it's going up 1 over 3. So 1/3. And it's not been reflected around the x-axis, so it's positive. This is a cubic function that shifted right 1, up 2. So x minus 1 cubed plus 2. Then we're going to ask ourselves about our shifts, or our stretches. You see how normally x cubed goes over 1, up 1? And this is, instead, I got to go over 2 to get up to 1. So that means it's taking twice as long to get up there. And if you kind of see it, let me do some erasing. This is a little harder to see. That's why I don't usually go by this. Normally, this goes over 1, up 1, over 2, up 8. Because we're cubing it, right? See, this is 2 over. I know it's at 3, but we've been shifted, right? So this 2, it should be up at 8, which would make it a 10, but instead it's only going at 1. So it's growing 1/8 as big. In fact, you see how that at 1, how it's very small? I'm gonna say it's this. No, yeah, 1/8, 1/8, because it should be way up at 8 when x equals 3, but it's only at 1. So it's been a compression vertically. I see a reciprocal function. I see, now when you're dealing with some reciprocal functions, remember and you'll learn more about this in chapter 3, the vertical asymptotes usually happens is the y-axis, and this has been shifted right 1, up 2. So we're going to write minus 1 plus 2 outside. And then, has there been a stretch going on? I don't know. It hasn't been, and this is what usually happens with the graph. There's not a reflection. If it's going like this, then it'll be a negative. It'll be a negative reflection on the x-axis. But this isn't doing that. How can we tell if there's a stretch? The best thing to do is think about the graph. Well, if x equals 1, y would be around, right? If I'm just thinking about the regular 1 over x. And that's what we're seeing there. I'm wondering if there isn't a factor of 2. Let's see, where's that? It's at 3. Let's plug a point in. Let's see if I see that blue line here. Let me get rid of my writing. So the blue line is the curve. I see when x equals 3, it looks like y is 3. So if x equals 3, that's going to be 1 over 3 minus 1 plus 2, which would be 1/2 plus 2, which isn't 3. So that means there's some kind of stretch going on. What if we do it this way? I haven't done this problem, as you can tell. What if we try finding the a? We know that it's going to be we know it's going to be a over x minus 1 plus 2. And we know we have that 0.33, so let's plug that in to our function. So 3 equals a over 2, because it's 3 minus 1 plus 2. I'm going to subtract 2. That's going to give me 1. A over 2. And then I'm going to multiply by 2. So a should be 2. So you see the way I suss that out? I figured that out. Not suspect. The kids who here at school are telling me I shouldn't be using the word sus because it's changing the meanings. But so I'm gonna go out on a limb and say that this is y equals 2 over x minus 2 plus 3. Go graph that in Desmos and see if I'm wrong. I won't here. So I see a square root function that's shifted left and up, and I see it looks to me like it's growing at the normal rate, so there's no stretch. So this is pretty easy. This is like the other one we just did. So it's going to be the square root of x plus 2 plus 1. I see a parabola with a vertex of 1, negative 2, so x minus 1 squared minus 2, and then instead of going over 1 up 1 over 2 up 4, it's only going up. I mean, maybe that's a half right there. I don't know, but I definitely see that if I go over 2, it's gone up 2. So that tells me instead of going up 4, it's been cut in half. Okay? So hopefully that gives you enough practice, has seen enough worked examples. You can go back and try those My Open Math questions if you haven't got them done yet.